Is it clear? Or you can add ChatGPT. Okay. So, hi Adam. Yeah. Okay, yeah. So, yesterday we discussed. Now continue. We firstly assume that we focus on inductive law. Okay. So we have equation 1. So equation 1 is the voltage equation. The voltage equation of synchronous generator. So, why? Because it's voltage drop. Okay. So what's the X? We should know what's the X. Okay. So here, this is some Vietnamese, but later on I will translate okay. Now we talk about, or later on we will come back to some Vietnamese slide. But now we talk about X. X, you know. So if we have armature winding, if we have armature reaction, right? That means we have this term, right? This term is made by armature reaction. Because if we have no loss, we don't have IA, so that means we don't have this term. Okay, so this term appears if we have armature reaction or we have loss condition, right? So what's the X? X is what? Of course, X is reactance, right? Reactance. But let me check X is what? X is of course, we have some description of X. Wait, oh, here, X here. Yeah. I highlight in red colors, but I cannot see it. Okay, so X is armature reactance. X is armature reactance. Okay? X is armature reactance. Okay, so we have V phase is EA minus J XIA overhead. IA is what? IA is phase current. IA is phase current. Phase current. And it's stable. So based on this equation, you can draw equivalent circuit. Okay. So now we have equivalent circuit. You know, this is source. Okay. So here, that means we just pick up one phase. We just pick up one phase to be equivalent circuit. Okay. So here. Sorry, this is DC. Here we have EA, right? And then here we have J's X. Okay, and the current here is IA over dot. That's all. That's all. Lock here. Lock. Okay, so this one is V phase. Okay, we have equation. We have equivalent circuits according to this equation. Am I right? Yes. So remember that this is single phase equivalent circuit. We just pick up one phase. The other phase will be the same. This is similarity for phase B equivalent circuit or phase C equivalent circuit. So we just pick up one. one place. Normally we choose phase A. Okay? Yeah. That is the reason we have this one, equivalent circuit. Equivalent circuit. Of course, here we should have the loss. You know, if no loss, no IA, we have loss, we have the values of IA. Okay? Yeah. What is it? So, what does this slide mean? So, this slide helps you understand why BS is perpendicular to IA. Why BS is perpendicular to IA? We know for BSE in the same direction with A star. Right? BS, okay, BNet in the same direction with phase. Okay? Why we have 90-degree difference between BS and IA? And this is the answer. This is the answer. So remember that. Faraday law. So when we apply Faraday law, we can calculate electromotive force E. So E is minus N derivative of phi with respect to time. Minus is because we have length law. If you don't know what's a length law, use ChatGPT. Okay, the ChatGPT will help you review what's a length law. Now, 1 minute. Ask ChatGPT, what's a length law? Okay. No. Okay. Yes, you are correct. Okay. Biến thuyền của tự đúng không? Từ trường với quan của dây sinh dây là vậy. Những mặt kẹp kính dòng điện tạo với từ trường chống lại nó. Đó là lens law. Okay. Yes, good. That is the reason we have minus here. Because we have the interaction between VR and BS. Okay? So now we have EI. Okay? So this is phi A. This is phi A. So we know phi A. Phi A is phi M psi omega t. Psi omega t. So if we have IAS, you can get phi AS. IBS, phi BS, right? So for phi B, t is phi M psi omega t minus 120 degree. And phi C, t is phi M psi omega t minus 240 degree. We just get of phase A. So here you get minus derivative of phi A with respect to time. That means you get phi M. Okay, psi omega t, you get omega cosine omega t. I am correct? Okay. You know, today I have the online Chinese class. Also, some friends help me teach online. Okay. Because I need to learn 5,000 Chinese words. Okay, so here. Oh, this is cosine. Okay, the same, the same, blah, blah, blah. So now we have here, then you get n sine or cosine, that's okay. Omega is. So minus cosine omega t, that means we can get sine omega t plus 90 degrees, plus pi over t. Let me check. Minus, right? Minus, right? Minus. Okay, you can check, right? For example, if omega t is 0, it is a minus 1. Minus 1, okay, so 0. Yeah. Correct. Okay? Yes? Yes? Omega t is 0, there is a minus 1 is 0, there is sine of minus 90, there is a minus 1. Okay? If this is 90, 0, it's okay, yeah. I like this. So, I have phi and I in the same direction. So, for example, here we have IA, right? This is IA, this is AI. Okay, and then we have EI. We have the same sine function, but now we have lagging harmony by over 2. So if here is EI, 90 degrees. Okay, similar. Yes. Okay? Yes. So here I have, look, the stator voltage, EI, lags, the rotor's magnetic flux, phi m. Sorry, this one is rotor, rotor. Not status. And this one is induced from this. Of this stator. Value. Yes. Okay. Yeah. So this one very easy for us, the many students, they can understand. Okay, but for you guys, you can use Google Translate to English because I'm lazy. Very easy. Okay, I think you can fully understand. Okay. Now continue. Look, we have X. X is the armature reactance, but inside the stator we have stator winding. Okay, that's stator winding. So for the stator winding, yes, okay, we get equivalent circuits. For example, this is phase A. Equivalent circuits. So equivalent circuits of face is I, and J is xi, right? X and xi, very different. X here is relevant to armature reactance. So xi here is belonging to the equivalent circuits of phase A winding. Phase A winding. Okay? So now if we consider Ra and JXA component of stator winding. Okay, we can modify this circuit. Become what? Now we have EA, right? Yes, we have JX, we have JXA, we have RA. Okay, and here this is rephase. This is rephase. Long. And this is IA over dot. Okay? Here. Remember this one for lacking dot. We mentioned before, we firstly assumed we have lacking dot. Yeah? Okay, so now we rewrite equation 1, right? Equation 1. So we can get what? That means we also apply vector 2. Very stable designs of white ball. Right? Very stable. You know, that means we need to have, instead of we upward and downward direction, we can view left side, right side. You know? And we can avoid these, you know, some hidden areas. Is it clear? Stable design. Do you understand what I mean? Oh my God. The smart university but stable designs of white ore. Do you agree with me? Why is it so stupid? Two reasons. Stupid person. Okay? The second reason is carefulness. Come back. Now we have AA is rephase is AA minus J's here. They are in series. So you get X plus XA, I overhead minus IA, over dot IA, I. That's all. That's all. You know, here they don't use over dot because they use bond phase vector. Okay? Remember, bond phase means vector representation. Okay? Oh, I don't want to give bond phase, I use over dot. We discussed yesterday, right? So here, for simplicity, I said here is XS. Again, X is armature reactance. XA mean winding reactance. Winding reactance. Winding reactance. Stator winding reactance. So if we combine, we can get XS. So XS is synchronous. S synchronous. Synchronous reactance. Okay? Yeah, reactance. So to be simplified, the questions is normally give you XS, but in your mind you need to understand XS is X plus XI. Okay? Yes. And here, this is voltage drop. Voltage drop. Okay, it's caused by stator resistance. Resistance. Okay? Yeah. So now, this is equation 2. Yes. Look, the armature reaction, the armature reactance plus winding reactance, you can get synchronous reactance, XS. And XS is X plus XA. Okay? Any questions? Questions? Any questions? Do you understand? Good. Yeah? Questions? So you are ECE 2022. Okay. So share some experience why you failed this course. Now listen why he failed this course.
Well, I think there would be a reason because I think I haven't attended enough classes for me to fully understand all the questions or example that you provided. Both, I think, yeah, you just want to.
Maybe next time you change, you shouldn't. I believe. Not I think because you have some experience. I believe I failed the course because of blah blah blah. Okay, just get in. Okay, now you have some experience. Okay, so maybe someone invite you to have a lunch together. He will share with you. Okay, some mistake and you can avoid this mistake. Okay. You know, for the final exams, we have a big questions. So a big question has many such questions. They are interlinking. So if you fail the first such question, that means next such question you also fail. Okay, that is the reason he failed this course. You understand? For example, question 1. Question 1, we have such question A, B, C, D, E, blah, blah, blah. Okay, so if you fail question A, all such questions are incorrect. Okay, and fail this course. Yeah, try to understand the first step before we go to the second step. Okay. Okay, so now, this is, I emphasize again, this is a phase. This is a phase. A equivalent circuit. You know, because this is phase equivalent circuit, so this is internal phase voltage, external phase voltage. phase current, phase resistance, phase synchronous reactance. You know, all parameters are phase parameters. You know, some stupid students, they use line voltage. Oh my God! See me again next year. Even though I emphasize many times, you know, later on we have some exercise, and I continue to emphasize, hey, phase, please. But they don't remember because maybe their girlfriend say goodbye to them. Oh my God. So we have a funny story. If you would like to buy this, but maybe you say goodbye with your girlfriend, and you focus on studying the public school. Okay? Just kidding. Just kidding. Okay. Good. Continue. So here we have phase A equivalent circuit, right? Phase A. Look, the equivalent circuits consist of the models for each phase. Phase A, phase B, and phase C. Okay, sometimes we say phase A, B, C. Sometimes we say L1, L2, L3. Okay, 1, 2, 3 mean A, B, C respectively. Okay, it depends on the national standards. Different national standard. Okay, sometimes we use phase A, phase B, phase C. Some countries use 1, 2, 3. Some countries use L1, L2, L3. Some countries use U, V, R. Okay, yeah. So it depends on the national standards. So in Vietnam, mostly use ABC. And we also have ABC, right? Maybe some student confuse U little a or capital A, right? Yes, of course. So go back to the transformer theory. We have the transformer. Okay, we have primary winding. We have secondary winding. Okay, so for primary winding, we must connect to what? Source. Okay, so for secondary winding, we need to connect load. Okay, and if we use little ABC, that means we emphasize the short side. Okay, and if we use ABC normally for secondary side, that means focusing on load connection. Okay. Anyway, go back because we don't have enough time to discuss this one thing. So now, fourth statement. Winding, we have equivalent circuits, phase A, phase B, phase C. Now we come to rotor winding. Very easy, you know. For rotor winding, we only have one winding. This is field winding. So we have field resistance. We have field inductance or field reactance. Okay, and we supply what we supply DC voltage. So here is VDC. Sometimes we use VDC or VF. F means there's a string. F means field. Okay, and we have field current. We also have adjusted resistance. Or we say variable external resistor here. Why we need it? because we can actively control the values of IF. So if IF change, okay, so if IF change increase, IF increase, that means phi R or BR or HR, increase. So if phi R increase, that means EA increase. Look here. EA. If EA increase, if phi M increase, what does this mean? Phi M? Phi M is phi M. So this one increase, EA increase. Okay? Yes. Yeah. Okay. Some students use IF overload. Oh my God. So stupid. Because this is DC parameter. Everybody know 0 degree. Right? Yeah, why they says IF overload? Oh my God. Okay. You understand? Yeah. Okay. So how can you remember? You need to do exercise. We have many exercise, many homework, and when you solve, when you answer the exercise, you can remember some parameters. Okay. So now this is theta. This is theta. Widening connection, right? Standard widening connection. Again, this is bond phase independence. Okay, so here we have Y connection, here we have delta connection. And now they say IS, they say IS. Why? Because XS, because XS is X plus XI. Okay? Yeah. And at the first class, I also give you the difference between Y connection and delta connection, right? In the first class, last week. Okay, so skip it. Skip it. But you need to recognize some parameters. Okay? This is internal phase voltage. This is synchronous reactance. Status resistance. Terminal phase voltage. Terminal line voltage. Because line voltage is the potential between one line to another line. We mentioned before, right? Remember the first class? Remember? Okay? Yeah. Look. So this is phase current. This one is line current. Yeah? Yeah. It's a delta connection, so V phase magnitude equals to line voltage magnitude. And yeah, of course we know, and from electric circuit we also have some theory of this. Okay, so okay. Now, yeah, I emphasize this. Okay, Y connection, delta connection. 1 minute. Read this slide. Think about it. Remember it. 1 minute, please.